this is Susie Newhan, and this is the one about solving quadratic equations. So what is a quadratic? Here's a quadratic. We know it's a quadratic because it's got an x squared term. If it had x to the power of 3, it would be a cubic and not a quadratic. If it was just 4x plus 10, it would be a linear equation. So we can always recognise a quadratic equation. We tend to see quadratic equations in this format. So we have to do a little rearranging when we're solving them if they're not in this format. So the x squared should rightfully be first, the x term should be next, and then the constant, the thing without an x, the number, would come last. So that's the way we like to write them. So why do we need to solve quadratic equations? Well, I've just come up with a few examples from economics that we use. So often we want to find the intersections of curves, and if one of these or both of these curves are quadratic, when we attempt to find the intersection, we will end up with a quadratic equation that we will need to solve. So when we're finding the intersection of graphs, we're solving simultaneously. So we set one curve equal to the next curve, and then we solve. So we're going to end up with a quadratic equation coming out of those. What else do we do? Well, if we're using a cubic to model our economic function, and we want to find a maximum minimum, say, you will know from your calculus education that we need to differentiate and set the first derivative to 0. But the first derivative of a cubic graph will be a quadratic, so we need to solve a quadratic equation. And often if we're just sketching a curve, if it's a quadratic curve, we'd like to quickly just find out where it crosses the y-axis, which means setting it equal to 0. So lots of reasons why we might want to solve quadratic equations. So back to the general form of the quadratic equation. So here we see that a is 3, b is 4 and c is 10. You get the idea. What about this one? Well, here, quite a common sort of quadratic equation, x is 1. B is minus 12, the minus is really important, it has to go with the number, and C is 200. So these two are also quadratic equations, but you'll see they don't have the full 3 terms, so this is the classic look of a quadratic equation. But here we haven't got a constant, so you could say, well, C is 0 here because you can't see the constant. Here, we've got a constant, but we don't have just the x term on its own. So we could say that b is 0 if we wanted to solve that one. So back to this. Sometimes we get a quadratic equation and it's not quite in that order because we want a, b, c. So look, here's an example. We've got the same terms, but the 10 is on the other side, so it's negative. So we need to bring that 10 back to this side so it looks like that. This one, the 10 and the 3x squared are on the wrong side, so we need to bring those back. And here the 3x squared has sort of escaped to the other side. We need to bring that back to that side. So you can see that with a little bit of rearrangement, we can get these errant functions into the right format. So this is the standard format. So we're now going to quickly look at solving a quadratic with the quadratic formula, which you will have learnt at school. You also might recall spending months learning how to factorise quadratics, but we're not going to do that. We don't have the time, and that's a bit historical because now we're going to use calculators and the internet to solve quadratic equations. Let's be realistic. But let's just quickly remind you of the quadratic formula, which used to be how we did it when we couldn't factorise it. So this one will work for all equations. So here's the equation, and it's such a glorious looking equation, isn't it? So there it is. So all we're going to do is, once we identify A, B and C, we're going to substitute them into this lovely equation. So just before we do that, there's might be a symbol there that's unfamiliar with you. It means plus or minus, because one of the key things about quadratic equations is they've got 2 solutions. Not all the time. There are certain situations where there are no solutions or there's only one solution, but in general there will be 2 solutions. So there's 2 versions of this, one with this bit is positive and one where that bit is negative, hence we get the 2 different results. So, for instance, let's say we want to solve this quadratic equation. So here are the values of a, b, and c, and I'm not going to do this myself, I'm just going to use PowerPoint. So here's the formula again. We now substitute in the values we know. We do the maths, and here's one result where we've got a plus there, and that actually gives us that value, and here's the other one where we've got a minus, and that gives us that value. So there are two solutions. Let's have another look. Here's another one. Here are the values of a, b, and c, and we're going to put those in, and we've got something a bit interesting here. We've got something minus itself, so we're going to end up with 0 under the square root, which means we're not going to get these two different values. So in fact, this is one of those examples where we have what's called a repeated root, a repeated solution. Only one solution. Actually occurs twice, but it's the same. And this might become, if we're solving a line and a curve, this might help us prove that the line is a tangent. But anyway, more on that later. So they don't always have two, but generally they will have two. And if you love this equation, you could get the merchandise anywhere on the internet for those people who really get into this. Let's look at the second method I'm going to use, and there's a multitude of ways of doing this on the internet. I've picked the one from math.com because it's a really good site, got lots of good tools. And if you go there and you go calculator source quadratic, you will come up with this beautiful calculator. So let's have a little bit of practice with that. So we want to solve this equation. We can see here like a is 1, b is minus 12, and c is minus 448. So we would pull this up on the internet. Here's the URL, and we'll just plug in those three numbers. That's all we're going to do. So here we go, we put 1 for A, B is minus 12, C is minus 448. Now here's the important bit. You've got to tick solve. So here we go, tick, see how automated it is, and minus 16. So those are our two results from this quadratic. Method 3 is some of the handheld calculators. There's a lot of scientific calculators, all look very similar, but only some of them will do quadratic equations. So here's an example of one where you can, but you can't see that very well. Anyway, I've taken a picture of it. So if you're lucky enough to have one of these calculators, they cost a bit more, but not hugely more. You will know if you've got this function. If you've got that function, then we go to option 2, polynomial. It wants degree of polynomials, so quadratic is degree 2, and then we just enter values of a, b, or c. So that can't be easier if you have one of those, but I'm quite happy for you to use the online one. All right, so let's just do an example from economics. So we can use any method we want to solve this, any of the three, but I'm going to use the online calculator. So look, here we are told, or we're reminded that maximum profit can sometimes be found when we've got marginal revenue equals marginal cost. So here's marginal cost, here's marginal revenue. And so we want to set them equal. So we'll set them equal and then we'll solve it. But in the process of solving that, we will see that we're going to get a quadratic equation. So here we go. So q squared minus 100q plus 2590 equals 574 minus 8q. All right, so it looks like we've only got q squared on one side, so this is going to be the side we're going to put everything on, because you will have seen that when we're solving quadratic equations, we bring everything over to one side and we set them equal to 0. So this A, B, and C idea only works if everything is on one side and 0 is on the other side. So we've got our q squared. So we've got minus 100q and minus 8q. So we're going to bring that minus 8q over, and that's going to become positive, isn't it? So we're going to have minus 100q plus 8q. So now we're only going to have minus 92q. And we've got this 2590, and we're going to bring this over to the other side, and that's going to make that negative, so we're going to subtract it from that. And I think that's going to give plus 2016 equals 0. So it's now in the form that we want. We've got our three terms equal to 0. So we can see that solving this equation, we're going to have A equals 1, we're going to have B equals 92, and we've got C equals 216. So let's grab our online calculator and to put that in, and here we are. So we're going to put in 1 minus 92, 216. We're going to press the solve button, and we get that answer, and we get that answer. So those are our two answers, or two solutions to this quadratic. So let's have a little think about that. Let's get rid of these. So if we plot these, here's the marginal cost. You see it's a quadratic in and of itself, which means it's a curve. The marginal revenue is a straight line. It comes just from multiplying a linear demand curve by Q and then differentiating it. These have obviously both been differentiated because they're marginals, and it's a straight line, so there it is. So in a simplistic world, if we're solving just two linear functions, marginal cost and marginal revenue, then the point where MR equals MC will indeed be the maximum point of maximum profit. But you see, we've got 2 points where MC equals MR. So we have to do a little bit of thinking here. So, but we do know, don't we, that every time the marginal revenue line is above the marginal cost curve, then we know we're making some money. So we're making revenue, profit all the way within this zone. Before we got to this zone, marginal revenue was less than marginal cost, and we weren't making any profit. And if we get to this point, where again marginal cost starts outstripping marginal revenue, we won't be making any profit there. So the question is, because we solved and found that Q equals 56 and 36, and indeed here they are. So 36 and 56. So the question is, which of those represent the point of maximum revenue? Well, hopefully you can see that at this point, it only just started going into profit. So when we get to this point, we haven't actually made any profit yet. We've just got to the zone where we're going to start making profit. Whereas here, we've been making profit all the way through here, and we're just about to slip out of it. So we know that this is a point of maximum profit. So, as usual, put some questions on the board, freeze frame them, get some practice, and then I'll put the questions, I'll put the solutions up in a moment. Okay, I hope that was helpful.